Welcome to Not Milk Never Milk. Subscribe if you're lactose intolerant.
You start by confirming components and getting immediate feedback from hardware. Pick an ESP32 or HC05 module so you have serial Bluetooth and enough I/O. Once you have motors, a compatible motor driver, and a 7.4V battery, mount the chassis and secure motors. Make sure to wire VCC, GND, TX/RX correctly. Double-check voltage tolerances. Then open the IDE and upload a minimal motor test sketch to verify rotation direction and speed. This prevents troubleshooting later. You now link Bluetooth serial commands to motor control logic, so the robot responds reliably. Map simple ASCII commands like F, B, L, R, S to motor driver outputs, and use PWM for speed modulation. This gives smooth motion and runtime efficiency. Once done, add debounce or packet parsing so dropped bytes don't cause hops. Make sure to read sensors, ultrasonic or IR, on interrupts or periodic checks to stop on obstacles, because autonomy reduces collisions and keeps the system. You finish by running end-to-end tests and validating user flow. Test Bluetooth range and latency with the actual controller device, then measure battery life under typical loads and confirm obstacle stops work. Once validated, tidy wiring, secure connectors, and optionally implement BLE bonding or a PIN to avoid accidental control. If problems appear, isolate them. Verify power rails under load. Confirm TX/RX baud and inversion, and log incoming packets to catch malformed commands. This single troubleshooting step catches most.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.